In this video, we are going to talk about the cosecant and cosecant inverse x functions. Let's first talk about the function of cosecant x. As you can see, this is my x-axis and this is my y-axis. The values that I'm considering on the right of origin is pi over 2, pi, 3 pi over 2, and 2 pi. And the values that I'm considering on the x-axis on the left of origin is negative pi over 2 and negative pi. I'm considering two values on the y-axis, that is negative 1 and 1. Before I graph the actual cosecant function, I would like to draw some vertical lines, and the vertical lines will pass through the multiple of pi. So these are my vertical lines. Now let's graph the cosecant function. So if I graph the cosecant function, my graph will look like this. As you can see, the cosecant function does not exist between negative 1 and 1. See right here, and the function does not intersect with pi. So technically what I can say cosecant function is not defined at the multiple of pi. So the domain of cosecant function is all real numbers excluding multiple of pi, and the range is from negative infinity to negative 1 and then from 1 to positive infinity. In other words, we can say that the range of the cosecant function is r minus this part negative 1 to 1, excluding the end values negative 1 and 1. And the periodicity of cosecant function is 2 pi, because cosecant function repeats itself at an interval of 2 pi. Now let's talk about some more properties of cosecant function. So as you can see, this is my quadrant plane. This is my first quadrant right here from 0 to pi. My second quadrant is from pi over 2 to pi. My third quadrant is from pi to 3 pi over 2. And my fourth quadrant is from 3 pi over 2 to 2 pi. The value of cosecant is positive in first quadrant, and the values vary from infinity to 1. The value of cosecant function is positive in second quadrant, and the value varies from 1 to infinity. The value of cosecant is negative in third quadrant, and the value changes from negative infinity to negative 1. Cosecant function is negative in fourth quadrant, and the values vary from negative 1 to negative infinity. Now let's talk about the cosecant inverse function. So as you can see, this is my x-axis. I'm considering two values on the x-axis as negative 1 and 1. The values on the positive y-axis are pi over 2, pi, 3 pi over 2, and 2 pi. And the values on the negative y-axis is negative pi over 2 and negative pi. Before I graph the actual cosecant inverse function, I would like to draw some horizontal lines passes through the multiple of pi. So these are my horizontal lines by dotted lines. Now let's graph the cosecant inverse function. So these are the graph of my cosecant inverse function. As you can see, the cosecant inverse function does not exist between negative 1 and 1. So the domain of cosecant inverse function is r minus negative 1 to 1, and the range is negative pi over 2 to pi over 2 minus 0, because cosecant function does not intersect with the x-axis. In general way, I can say that cosecant function does not intersect with the multiple of pi. If I consider the function for the range negative pi over 2 to pi over 2 minus 0, then that branch of cosecant function will be these colored part with the red color, and they are known as the principal value branch of the cosecant function.